All right, I did a video earlier about picking this piece up, actually in a vertical. So this was a pipe that was going in the ground, and this piece here was vertical, and so that was the pick. So the configuration was a little different. This one here, they're going to pick it, and it's going to be a horizontal, flat horizontally, right? So you're looking at a top view of how they want it to pick. And so they're going to pick it up. It's really not going to change orientation. The other one picked it up and it rolled. This one's going to stay flat. So what happened is you need to find the center of gravity of this whole object. In this case, it's a uniform body. It's a steel pipe. So when you have a uniform body, you can just use the lengths as the weights, right? And then you're going to do a center of gravity calculation, or process to find this point right here. So where if you were to pick it up from this point, it would pick flat. So it's perfectly balanced. So I'm going to show you how to locate that point. So this the dimensions is 10.5 by 25, and in this case it's to the center of this elbow. So you're gonna take this distance, which was 10.5. It's really 10.6. So if it's all together, you don't know it's 10.5. You're just gonna measure it. You're gonna locate the center of this, right, and then the center of this, and you're gonna measure that. So technically this should be 10.5, right? But, and then here's a little different, right? You're going to do the same thing. You're going to mark the center of this pipe, and you're going to measure that. It just comes out a little different than what the actual, because I don't know why. Cutting across, anyways. Mark the center of the pipe, elbow, and measure from the end to the center, and that's your dimension. So let's get rid of that. And let's get rid of that. And in this case, we got 24.8. I really don't know why that's different. Oh, because the center of this is actually different than this distance to the center of the pipe. Yeah, it's not. So this leg here is not actually going to there. So, right, it's only going to the center of the elbow, and that makes a difference, right? Here, it seems like, okay, yeah, so that's why the difference, that's why it's 10.26, not, I thought it was an eighth off, it's quite a few inches smaller, because this is 6-inch pipe. So now what we're going to do is we're going to take that dimension 10.26 and find the midpoint, right? So, right here, and then Control K will set me to the center of that red line. Right, and then Control K will set me to the center of this line. It just needs to be, it'll be 3, whatever that dimension is, 5.13. Just dividing it into 2. And the same thing here. So I'll write down that measurement, because if this is the case, you're going to have 12.4, which is almost 12.5, 12.5. All right, and then you're going to mark that midpoint. And then you're going to take a string and tape it here and run it to here. So now you're going to measure it first, 13.72, and then you're going to put a string, either clamp it or hold it, or you could just run, it's better to run a string or something, right? Measure it and then run that string and put it in so it's kind of permanent, because you're going to need the line here when you get this measurement. So you're going to measure 13.72, so it's 13.9 1/4, and we're looking for this dimension. We don't know it. It doesn't exist yet, right? So I think that's part of the unit here. Oh, yes. Delete. All right. So we have 13.72. It's a field measurement, and then we're going to calculate. So you're going to take the weight of this one, but in this case we can use the length, the measurement, the dimension, the length of the piece, and the length of this piece, because it's a uniform. If it had varied thicknesses and coatings, you'd have to start doing individual pieces. All right, so you're going to take the weight, which is here, and this line is called the arm distance. So when you start here, the arm distance is 0 because you haven't traveled along this line at all. So technically it's 10.26 times 0, 10.25 times 0, plus, which I don't think they usually, doesn't usually get in there, but I can't remember why it would be important to know that. But then you're going to take this distance, take 24.80 and multiply it by the distance that you field measured here, 13.72. Then you're going to divide that by the total weight, which is 10.26 plus 24.8, and it's in parentheses, right? So you don't, if you're putting it in your calculator, you'll get the right answer. And then you'll end up at 9.707, right? Or 9.71. I don't know, there's a little difference there. And no, there is no difference. This is what you're measuring, right? So let me change this to 0.6 and point relative. I think the computer's been on too long. There you go. 9.71707, yeah. And then that'll give us that distance there. It's actually a little different. Not sure why. Maybe I used the computer to give me the center. Weird. I'm not editing this, so sorry. Point relative 9.71, enter. I think there's a difference because I use the computer to find the center of gravity. And this is going to be only approximate because we're not finding the center of gravity. This one, then the center of gravity, this one, finding the distance, but the center of gravity between the two, and then the center of gravity of those two to this one. So there might be a little difference, and I'm rounding here. So, and now we have that point. Let's draw that point in. All right, and then you're going to run your slings, attach your slings here and here. And in this case, it's more important that they're exactly on the, if you're lifting it vertical, it just needs to be above this line. If you're above this line, when you pick it, it'll tumble this low end here, the pipe, the elbow end would, it would go lower. If you're this side, it would go higher. So we need to be perfectly balanced. You're going to put them in exactly those 2 points. And then when you run your slings, the slings need to be directly above that point when they're tight, right? So that's it. So you're looking at a plan view here. This is from the side what your slings would look like. They have to be lined up over that point. And then there you go. That would actually get you your pick. So if that's kind of a difficult pick, but not that bad. But if it could be pretty difficult to balance it out. If you get that line right above that point, no. However, if you move these 2 points away a little bit, then you ran a third sling like right here. All right, a third sling there, so you have this side view would have another one right here. All right, then you'd have more stability. You just want to push this way a little bit, right? And then that way you want to tumble. It wouldn't be holding much weight. You could, I would not use it come along on any kind of a pick, but you could put a small one with an adjustable shackle on it or something. And then this one you could have a turnbuckle or a shackle. This, if it's barely carrying any weight, I won't make any recommendations, but it wouldn't take much to hold it level. You should properly use a sling. All right, so that's pretty much it. And then I'm going to send you this PDF if I get your email, and it has kind of the steps and explaining why that you can use this dimension as the weight, and this dimension as the weight. You can replace it as the weight because it's uniform. It's going to be 24.80 pounds, 24.80 thousand pounds. It wouldn't matter if the body is uniform in its this length, just a uniform body. It's the same pipe or the same material, and all the way through, same material throughout. All right. Hope that helps you get your pick safely, and thanks for watching.